Is Mr. Biplab going to have another presentation
No,
or
no, no,
same
no.
presentation?
Same presentation. Myself, Biplab, and Dr. John Horn, Dr. Pal, and Dr. Horn, both will be there
Okay.
with me. Yeah.
Okay.
Yeah. Both will be joining from Baltimore. Actually, Biplab was here, but he just flew back.
Okay.
I think few days he was here. So his dad was not well, but he's gone back
Oh,
just now. Yeah.
okay.
Can I do the broadcasting? Because everyone is waiting.
I think we should start at 6:35, please.
So his dad was not well, but he's gone back just now. Yeah. Are we live, Deepika?
Not yet.
Not
Like
yet.
in just few minutes will be. Like, is everybody from your team joined? You mentioned somebody from Kolkata and US will be joining right now.
They have joined. The Kolkata one, I think they're in the audience, possibly. And Biplab, have you joined by any chance? Bip, have you joined? We can start actually. They'll be joining because there's no point in holding back others.
Right.
Yeah.
Okay. So I'll just request for the webinar.
John, have you joined? Okay. Early morning. That's fine. So let's not hold others. Yeah.
Hello, everyone. We welcome you to IIB's series. So just give us some time. The event will begin in next 2 to 3 minutes. Thank you.
I believe this is a Calcutta Howrah Bridge, right?
Yes.
love to do a digital twin of this someday.
Oh, wonderful.
Sure, sir. Hmm.
Have you prepared any digital twin of any other bridge right now
Uh,
so far?
Not exactly, because we haven't done it, but I'm talking to, Atul Bove is also here. Atul is here.
Okay.
So we are actually actively collaborating on this. It's been done worldwide in some other
Yes,
countries.
right.
Yeah. So we are actively collaborating on this. How can we bring it in India together? We're in talks.
Okay.
It's more on the steel bridges actually. Yeah. So our work so far, a lot of work was on the concrete side.
Okay. So, should I start the event? Is everyone okay with it?
I'm okay. Puri,
We
ask
can get
Puri
started.
sir.
Yeah.
Yeah, yeah. Ask Puri sir. Yeah.
No, please go ahead. If the presenter is ready, then I think we can go ahead. Everybody knows about uh, this institution very well. So in between, you can, when the other people come, I think we should go ahead.
Okay.
Yeah, yeah.
So, everyone, please welcome to IIB's lecture series, special lecture 24. And I welcome you all to this lecture series. So, to begin this event, I would now request Ruhi to please present the video of IIB.
Yeah, sure.
This will just add a glimpse of what IIB is doing so far and what levels have we reached upon. Thank you, Ruhi. Thank you, Ruhi. So that was a small introduction about IIBE. So today our topic that we will be having a lecture on is digital technologies in structural health and public safety, a new frontier. So to start this event series, I'll just introduce you to our today's moderator, Dr. Prashant Motwani. So So Dr. Prashant Motwani holds a PhD degree from Indian Institute of Technology, Bombay, India, and bachelor's and master's degree in civil/structural engineering. His research interests center around replacement of steel pre-stressing strand with fiber-reinforced polymer bars in pre-stressed concrete structure and monitoring structures through smart sensing solutions. In 2018, Dr. Motwani received the prestigious Commonwealth Splits. I am extremely sorry. In 2018, Dr. Motwani received the prestigious Commonwealth Split Site PhD scholarship and visited Queen's University in Belfast as research associate. While working at Queen's, Dr. Motwani implemented a novel manufacturing technique to produce smart FRP bars with embedded fiber optic sensors. Dr. Motwani has published several peer-reviewed journal papers on FRP materials, fiber optic sensors, and finite element analysis. Dr. Motwani has also presented his social views in two TEDx conferences organized in Delhi and Rajasthan and has written over 250 articles in Q&A platform Quora. So with this, I welcome you, Dr. Prashant Motwani, and hand over you this session. Thank you.
Thank you, Deepika. Thank you so much for the introduction. I'll introduce our special invitee today, Dr. Lok Tat Sang. It's actually my honor to introduce Dr. Lok to everybody. Dr. Lok served as associate faculty in Nanyang Technological University, starting from when I was born in 1991 till 2006. And then from 2006 to 2019, served the position of Dean of Student Affairs, and he retired recently in 2019. And subsequently, he started two companies, PHM Technologies, which is basically a blast protective security advisory practice, and also a structural health monitoring company known as Novel Intrinsic Smart Sensing Solutions. Sir is the acting chairman for the company. Through his two companies, he provides guidance on the effects of air blast, ballistics penetration, sensors with advanced wireless, low-powered, and energy-efficient sensors for structural health monitoring applications. Personally, I know Sir since last couple of months only, but I can tell you from my personal opinion that there has been never a case when I did not receive a response within half a day from Sir. So, Sir, it's really an honor knowing you. Thank you for attending this presentation. We'll take your views after the speaker has presented the presentation, sir. And then we have our panelist, Dr. Surya Prakash, sir. Dr. Surya Prakash, sir, I'm really glad that you remember me. I met Sir when I was still a sophomore at IIT Bombay during the ICCMS IIT Hyderabad. Dr. Surya Prakash is the recipient of prestigious Ramanujam Fellowship from the Government of India. Before joining IIT Hyderabad, he worked as a design engineer at Structural Group and Company in Baltimore, USA. He received his PhD from Missouri University of Science and Technology, USA in 2009. He obtained his master's in MS degrees in structural engineering from IIT Madras in 2005. His research interests include use of advanced composite materials for civil infrastructure, precast systems for affordable housing, and repair and rehabilitation of structures. He has 15 years of research and teaching experience, guided 4 PhDs, published 65 research papers in internationally reputed journals, and presented more than 50 papers in national and international conferences. He's also serving as the Associate Director for ASC Journal of Bridge Engineering and a member of ACI, ASC, ICI, and ASTR. Thank you so much, sir, for joining today for the presentation, sir.
Thank you. It's pleasure is mine. Yeah.
Moving on to today's presentation, there's always an implicit handshake between the society and the engineer. We hardly have a choice but to trust what is constructed is safe. When an engineer approves a design, it always assumes that everything is safe. But as they say, to err is too human, and that includes us engineers. That brings me to today's topic on how our intention should be to catch such design mistakes through enhanced methods such as structural health monitoring. And this brings me to the topic on Special Lecture 24, Digital Techniques in Structural Health and Public Safety, a New Frontier. Introducing our first speaker, Dr. Biplab Paul. He is currently the CTO and President of Machine Sense LLC based in Baltimore. He has more than 20 US patents in Internet of Things and sensor technology, of which 2 US patents are in structural health monitoring. After having a PhD in telecommunication engineering and integrated MSc in physics, all from IIT Kharagpur, he has worked as senior R&D manager in leading telecom company like Sina Corp and sensor company like Entrust Jose. Thank you so much, sir, if you are here for joining us for the presentation. Our second speaker is, can we go to the next slide? Thank you. Our second speaker, which I think those who have already attended the previous lecture, you must have already heard a 15 minutes short introduction from about our second speaker, but we are glad we have a bigger slot now, sir, for you. Mr. Sundar is a civil engineering graduate from Bengal Engineering, University of Calcutta, postgraduate from IIT Bombay, and leadership program Ross Business School, University of Michigan, Urbana-Champaign, USA. He has completed diploma in cyber laws from Government Law College, Mumbai. He has 27 years experience in IT and digital for marketing for multiple industries in India, Europe, and USA. Mr. Sudeep has been key to L&T Construction's industry-leading digital transformation between April 2017 to September 2020. He has been an invitee member to Transportation Infrastructure Board meetings for digital-enabled business transformation. Mr. Sudeep also headed IT and digital for KEC International RPG Group between 2013 and 2017. Now I hand over the stage to the speaker, and we'll have the panel discussion after the presentation.
Thanks very much. Should I go ahead?
Yes, sir. Please go ahead, sir. Share your screen.
Yeah.
Hey, Sudeep, I sent you a little revised that slide altered presentation. Do you have that?
No.
Okay.
No, I don't have that.
That's fine. Then go ahead with what you have. No problem.
Yeah. Can you see it?
Yes, sir. We can see the screen.
Very nice. Let me just, Okay. First of all, good evening, good morning, good afternoon, wherever you are. Biplav, I know you're in the morning zone. So it's an honor to be here and present something we believe is an emerging field, though it's not unknown, but technologically we believe there's an emerging field globally. So we thought that, let us take this opportunity and talk about what we are up to in this field. And indeed, it's an honor to be here in front of a grand, audience who have got collectively possibly, probably 17 to probably 30, around 2001 years of civil engineering experience. And to be honest, I'm a civil engineer. Very few people know that I was actually for 3 months SDO irrigation in Government of West Bengal, but I didn't continue. I came to IIT for pursuing my post-graduation, and then I went abroad. But I still believe that it's time to come back to my original field and based on my experience and contribute. And in that process, actually, I got Biplav, who is equally committed and into emerging field as a technology master. And then I found that, some of the people very like-minded who are over there and trying to change, trying to dream something big. Now, let me just go to the next slide. Before I go into the main presentation, what I'd like to do is, sorry, this is, I'll have to change the slide deck because this doesn't have the videos. Just 1 second. Just give me a sec. I'm sorry for this.
No problem, sir.
advice करा.
Yeah, I'm there. Sorry. Sorry about that glitch. So before I go into this presentation, I'd like to show some of the failures that we have seen in the world, and whether it's a bridge, whether it's a tunnel, whether some other structures, right? So therefore, structural health monitoring is important, but structural failure is not something that it happens in India and it doesn't happen outside. This is typically, if you see that, this is in Osaka, Japan. This is an arch bridge failed because of a massive rainstorm, right? It's a question mark why it failed, whether it was being monitored, etc. But certainly it failed. The most importantly is failed. Now, whether it's a monitored or not monitored, I'm not very sure of, but it's Japan. So we believe that that possibly was being monitored. If I go to the next one, it is Taiwan failure.
A 460-foot-long arch bridge crashed down in a coastal fishing village. It caused an oil tanker truck to fall and burst into flames. Boats in the water below were crushed. 6 people are believed to be trapped on one of the vessels. An Air Force helicopter, as well as more than 60 military personnel, are searching for possible victims. 10 people were taken to hospitals, 6 with serious injuries. The collapse happened hours after a typhoon swept by the island.
So important is, again, they're talking about the weather and they're not talking about monitoring side of it. But I'm sure the weather is one of the catalysts. But the bridge possibly was weakened for some other reasons as well.
A 460-foot long.
Let me just go to some other structures as well. You know, we believe that SHM as a subject is pertinent to all kinds of structure. This is a failure in Edenville, Michigan last year, just before the COVID, when $2 billion damaged the downstream. It's an earthen dam.
There it goes. There it goes.
This gives me a goosebump actually when I look at it.
There we go. There's the rush.
And interestingly, this earthen dam failed in February 2020, and it was cleared as fit in December 2018, just 13 or 14 months ago, and by the respective authorities. So what it means is, and I personally feel that, you know, within 12 months, it doesn't happen. It must have started long ago, possibly with the water seepage from the upstream to the downstream, what was happening, and we could not see it visually. We could have done it possibly different ways, but we could not see it. Today, understanding the seepage inside the soil, compacted soil, from one corner to another corner, it's so easy to do it through sensors. But I believe that there's nothing, and I believe, but I know that there was nothing. It's all visual, and it's US in 2020 I'm talking about. I go to the next slide. This is a tunnel failure in Japan. So I'm talking about the US, Taiwan, Japan. These are all developed countries, so obviously I don't have that much of a picture here. But this is important to set the tone that why we need this.
Overseas tonight in Japan, where outside Tokyo, cars and trucks were passing through a 3-mile-long traffic tunnel when the ceiling began to cave in, triggering a fire, trapping drivers inside. Tonight, they're still searching through the wreckage, and ABC's Akiko Fujita is in Tokyo tonight.
Grainy surveillance video inside the tunnel show the frantic efforts to save those trapped. Japanese police say these large concrete ceiling panels, as many as 150, came crashing down, sparking a fire on this major highway connecting Tokyo to central Japan. Witnesses describe a scene of chaos as people ran to safety. Flames and smoke billowing through the 3-mile-long tunnel. One truck driver, trapped under the rubble, called for help, but there was so much smoke, firefighters had to halt rescue efforts, fearing another collapse. Late Sunday, rescue crews pulled the charred remains of several bodies, including the truck driver. Investigators are looking into what caused the panels to collapse, but say the tunnel had just passed a routine inspection in September. Akiko Fujita, ABC News, Tokyo.
Overseas tonight.
So that's the tone, actually. I just wanted to set, because it's important that we recognize today that it's a matter of public safety, that we should we should go for some kind of maintenance. I mean, I know that it happens, and that's what exactly we're going to talk about. But we'd like to also talk about a little bit old to the new ways of doing things, and that's there lies actually our possibly digital experience and your experience as a brilliant civil engineering people, and how do we actually mash up ourselves and save for the future and give a more safer world in future. Right. If I look at the bridge stats in India, is again I must say that Atul Bove Atul told me some of the statistics. 170,000 bridges, 21,000 bridges are so-called deficient. Possibly, I mean, either way you can tag it, but it's basically needs intervention, some kind of. And 3,000 bridges possibly more than deficient. Now you call it unsafe, you call it something else. It's a separate things. And also we looked into, US has probably more than 90,000 bridges. Denmark has 9,000 bridges. Sweden has 22,000 bridges. They need attention because, those countries actually, post World War II, there are lots of bridges which actually started with 100 years, but because of the weathering and because of the explosion of automotives, actually there has reduced the lives of those bridges, and they need to be monitored at this point in time. And that's why the SHM is a global need. And at this point in time, it is, if somebody tells me or tells you that they know it all, I think we need to look at it, what they know, but it's not to doubt anybody because it's a field that is emerging. Right now, what is it that what we used to do? In fact, I was talking to some of you are there in the audience over the last 15-20 days, and Bongirwaji is a great teacher of mine in that way, and I've got a few more in this process. Important is, what we do is basically all physical today, right? We send, you can see the picture also. I know that one of the companies do it day in and day out. They basically have got a gantry and they send it and kind of try to do it. But at the end of it, those two gentlemen who are doing it at the bottom of the truss, you can see, right? It's all visual. They want to see the visual, the cracks, the rusting, the subsidence, the breakages, the corrosions, all, whether it's a steel or it's a concrete. They look at it physically. Probably they take some photographs, and later, I don't know whether they do image analytics, which is basically, it is a part of AI, artificial intelligence at this point in time. And I believe that I haven't seen it, to be honest. And if somebody does it, fantastic. Again, important thing is that, the current ways of doing things is a lot of testing is done or are done, during the construction, and that becomes the baseline, and you start from there. I've seen very few cube tests failure in my own life, whatever I've seen last 7-8 years. Most of the data that you have today, the static data, sometimes quarterly, sometimes once in 6 months, sometimes monthly, discrete data. You don't have the continuous data. Most of the places it's not in one place I'm talking about. And you put it in the Excel and try to take a graph and show it as. But actually, any structure, it gets the stress and the strain continuous basis 24/7. And we can't predict on a 31st or 1st that there'll be more. And it's very difficult to say that is a representative of the entire year. Another thing is that what I've seen is, again, being a student, and I'll always be a student in civil engineering, that most of the work is basically Z-axis. We take a Z-axis view, and then codes, IS code or the Euro code or American code, they take a factor of safety so that, X and Y axis also can be covered, right? That's obviously factor of safety approach, one approach, but we believe that time has come, the technology has come to look at actual what's happening at the XYZ axis. Last one is, if you look at the remote monitoring, extremely difficult. In fact, I was looking at the Bogeybill Bridge recent tender, actually, which happened on Brahmaputra River. And it's an ideal case, extremely difficult, 17-kilometer long bridge. How do you monitor that? And especially during the time of COVID, you won't get even a single guy to go over there. So important is the present health monitoring is having, it's visual, mechanical, little bit electrical entity is there, obviously, and discrete data. Now, with the advent of new technologies, here comes Dr. Biplav, actually, who will be talking about was the next couple of slides, that what has happened in the sensor technologies, given his worldwide experience. Biplav, can I just bring you in that, why this is relevant today? Your experience, your researches are so important for civil engineering field, given the development in these sensor technologies.
Sudeep, thank you everyone, and thank you for attending this seminar. So, as you know, I'm not a civil engineer, but I certainly am finding that area of structural engineering immensely interesting when I look at this progress that has happened in our semiconductor area. So I'll give you a brief what happened in semiconductor industry in last 4 decades. So typically in every 1.8 years, we have doubled the capacity to process the data as well as to memorize the data. And we all know that because, all of you have a smartphone and you've seen that you don't like to keep your smartphone for more than 2 years because a new model comes up who has a lot more memory and speed. So we still go into the new. Now, what's its impact in sensor area, especially data-driven area? If you look at this curve, what you immediately understand right now in a size of a coin, you can have a entire single board computer that is more capable than any desktop computer that you have been using back in 2005 or 2010. So what it does, it allows you to process lot of sensor data. In fact, a lot of advanced algorithm, like you can run a lot of machine learning, a lot of advanced rule engine, high level of regression at sensor edge. And this has an immense implication in civil engineering area. So can you go to the next slide, Shraddha? Can you go to the next slide?
Yeah,
Yeah.
I've gone in. Yeah.
Yeah. So now I'll give you a classic example why the IoT, edge computing, 24/7 monitoring or cloud makes sense in the view of such an advanced computation. I give you an example from our own patent that we filed for measuring three-axis deflection. If you are aware of this area of structural health monitoring, the only data that civil engineers can possibly match with their modeling is the three-axis deflection data. Because whenever you apply load to a structure, many point of the structure will experience deflection, opposed three-axis deflection, and usually that can be modeled. But what happened is measuring that three-axis deflection in real time on a structure like bees or tall building is extremely difficult. In fact, the current method is laser-based, which does only sometime one axis, sometime two axis, sometime it can be three axis if you actually do, but it's super expensive. Like in Indian rupees, it runs in crores of rupees. Now I'm giving an example how that advance in silicon technology can make it so easier and can be very cheap and can be very affordable. So what we did is we use a concept of 3D campus, meaning, if you allow a magnet to rotate alongside a structure and try to measure its orientation of the field using a strong magnetometer, you get a lot of vectorial data real time. But the problem is you're having so much of volume of data, you have to analyze then and there on sensor itself to understand what is its deflection that is reflected by the magnetometer reading. And we run advanced machine learning itself on the sensor to understand even 1 micron level of deflection. I mean, we have done this thing for last 2 years, and usually the 10 micron is the resolution that is expected by all the IS code, but we can get even to 1 micron level accuracy in terms of the structural movement using this kind of advanced edge computing, which is, by the way, would not have been possible without this advent of the silicon technology, because right now those things can be done at a very affordable cost. What does it mean is that now all of a sudden you have a structure where you can have, you can embed those sensors all along the structure at a pretty insignificant cost, and you can look at its three-axis deflection with a dynamic load, like whenever the track is moving or any kind of, it is subjected to any kind of wind or any kind of stuff that Sudeep has shown that can lead to the disaster. Now, along with it, you can see there's been tremendous progress made in terms of the GPS and GNSS technology that can also monitor the, I would say, almost millimeter level of movement of the structure, and you can do it from the satellite. Then you have a lot of embedded sensor, meaning the sensors that can be embedded inside a concrete, and we might talk about that a little later. So when you are actually marrying all this possibility of low-cost sensors that are continuously sending the data, being analyzed locally, and those data are being transmitted over wireless network to cloud for everyone, it's an immense possibility of looking at long-term trend, looking at some of the measurement that I just give you an example of three-axis deflection that was never possible even. So you are looking at a long-term failure data of the bridge, why the bridge is getting failure. You're also enabling a lot of measurement that was not possible. You're having the visibility all the time. And you combine all of this, and this gives you a new paradigm of structural health monitoring where you certainly, I would say that any failure will not be at your hindsight. I mean, if something is wrong with your structure, certainly all of a sudden you are gifted with a lot of data and insight. And in fact, we can give you the SMS and email alert that, hey, look into this because this part of the bridge structure may not be looking good because maybe we are sensing the bridge is moving from elasticity to plastic reason. Yeah, Shudip, go ahead now.
Yeah, thank you. I think that's one of the things that I know Biplo is a king in that in his space, and he can just go on and on. Let me just bring back one of the important things here that Biplab touched upon, the laser technology. And I see when I look into the market, actually many of the bridges, you go to the vendors who actually give you the laser technology. The question is that should you use the laser technology, which is expensive? Should you seek for some alternative? Laser technology gives a discrete data. It doesn't give a 24/7. If you want to make it a 24/7, that means the laser has to flow in every sub-second level, actually. And if you want to do a meaningful analysis, laser is not the probably right thing. You can get some data, discrete data, as I said to you, but continuous data is not possible. So these are things, one of the specs I have seen recently. Somebody is asking for a particular sensor, which is GNSS, global navigational satellite system, which actually works with the constellation, right, or even the artificial satellites. Why do you need it? Do you really need it? And it's expensive. You need to know that there are people who are there who have got some patents in there, and it may be quite expensive. So we can actually look at, because it's an engineering solution that we are doing as much as the design you do. This is also a solution that we have to do, right? So there are some specs which are actually, in our view, actually even older. Even 2 years specs are also quite older. We can work together with you. What are good and what are not so good, or what are possibly old at this point in time, even if you got it 2 years ago. Now, very quickly on this, why do you need to have a structural health monitoring? In fact, we were just asking ourselves for some time, the last 2.5 years, when we came to the market, we were thinking of, can we look at 24/7? That's very important thing that I talked about. And can we monitor all three axes, as people have talked about, right? Does the structure need a major maintenance soon? How do you understand that from the data itself? Sensor is just one part of it. So you can put a sensor, it's an ornament to us. Sensor will help you getting the data. But then what? How will you understand? How do you assess? Does it really require monitoring? Maintenance at one or two sections. Similarly, if you look at daily and the seasonal deflection and recovery time, have you ever measured it? Whether it's in the night when there are loads of trucks going on, how the deflections are the soil laden, the lots of soil and the aggregates laden trucks go over the bridge, how it happens, how it behaves, right? Similarly, we'll have to look at the temperature variances as well. We know that in some of the places where the temperature goes between 4 to 40 degree, and how does the variation happen? In fact, we'll like to talk about it a little bit with the data, right? Similarly, we are talking about can we predict in future, of course, the residual life of a bridge or a structure, right? Based on the continuous data, based on data for a substantially long period. So only what is the rate of deterioration? Now, deterioration is elastic property. How the bridge is going into the into the plastic property zone. Now, steel and concrete could be different. It's more on the we have asked this question on the concrete side. Now, we are asking these questions, but we believe that the Machine Sense as a company, actually, we are in a position to think innovatively. Why? Because the company is a 2014 born company, is 5-6 years only. And as Biplavi himself is one of the co-founders of this company, we've got John, who is also another PhD, he's working on this. And the guy who founded this company is basically Conrad Bessemer, who is I told you last time also. He's a man who's he's a great grandson of Henry Bessemer, who is the inventor of steel, right? So it's in the gene. And we believe that we are the company, we believe that we can actually challenge this part of the world, not only because of the heritage, but because of the gray matters that we have and we are hiring. Now let's go to the end-to-end solution part. What do we do actually? If you look at, there are three basic blocks at the top, right? One is the basic building block to us. Second one is design and build the software, what actually processes. And the third one is actually which does the analysis, actual analysis, which is actually going for a causal analysis. What is the effect, what is the cause, and why it is happening. All whys are to be actually based on the data at the right hand side. So basic building block is basically sensor, different kinds of sensors. Of course, there are lots of patents, lots of big work, physics work happening at that end. Though it's very small, we have written the sensor getting sensor data, but sensors could be of various types, of various technologies. After that, once you get that, we actually process it through the gateways. Even the gateways could be extremely sophisticated, right? And then once we get that, the data through the gateway, we put in the cloud. And why we put in the cloud? Because we've got the storage space today. We've got the storage, we've got the massive computing power. People have talked about the algorithms. And interestingly, those algorithms today actually can run on the chip as well. Now, even on the sensors as well, because we get the space. Even on a thumbnail size computer also, can process terabytes of data today. So thanks to the technology. And once you do that, there's some basic analysis you can do on the cloud or on the local server that you have kept, the data is being kept. So what kind of data you can do in that, normally if you look at anyone you call, they will be showing you some kind of time series data. And we also show the time series data. Time series data is nothing but, what's happening over a period of time. I'll show you something from one of our Kolkata bridges in this presentation. But actually, the fun is processing terabytes of data when we look at the patterns coming up. And we'll show you some of those stuff. So that's the analytics part. So both the sides of it are hugely important. Getting data, analyzing data is important. But at the same time, in the middle part, if you don't have the right kind of software, which can process that, we can gather data, process the data, we may have a challenge, right? Now, bridge monitoring data flow. Basically, if we look at, as I said, 6 steps. If you look at the 6 steps here, the same thing. Actually, you can see it over a pictorial diagram. Yes, and I know that you know it very well, so I'll not delve much of time on this. But important is, at any, whether the cable level sensor or at the girder level sensor or at the bearing level sensor. And in fact, we're talking about the scouring sensor as well. I know that I've been given a challenge to look into, can we get some sensor to measure the scouring, actually, post-flood situation. And thank you, Bongioji. Definitely will be looking into that if something is there in some part of the world. And we don't have it, but we have got necessary wherewithals to approach many others. So another important thing is that, if the laden trucks are going or the trawlers are going, so validation engine, which is basically through the CCTV cams, etc. What you used to do earlier with the manual checks, visual checks, can be done today through drones. All these feeder actually can go into our cloud, and from the cloud actually we can do the analysis, and we can actually show it on the mobile as well as on your computer. And it's as easy, but again, there are 2 parts of it, as I said. That one is the time series analysis, which also has got a lot of sophistication, but even more sophisticated ways is, how do we get the causal analysis? So if you look at what do you monitor in the bridge system: deflection, acceleration, strain, temperature, load, inclinations to scouring. These are samples only. Lots of other things can be done, and different structures have different types of data to be gathered. And for that, it doesn't mean really one size fits all, because every type of data we'll have to look at it, what kind of sensors you need, and whether how modern they are, and how expensive they are. Also, we have to look at the cost effectiveness as well, right? So and the we do have the tunnels or the bridges in the Himalayan region, where we need to monitor the seismic vibrations as well, and we need to gather that data. Not only gather the data, but also vibration also not to be nullified through the effectively through mathematical algorithm, that which part of the vibration is because of earth movement, and which part of the vibration is because of vibrational deflection, is because the loading pattern of the vehicles, or possibly other like winds and other elements, right? Now, if I look at a holistic system, that's what we are talking about. Holistic system is basically, there are different types of data. So if you look at whether it's a accelerometer, whether the vibration and the deflections, etc., to the drones and the pictures, basically drones and CCTVs, or any other normal pictures as well. Similarly, maintenance records. We believe that the past maintenance records also have a bearing on the structural health monitoring, because if you have been doing some minor maintenances or few major maintenances over the last 5 years on a bridge, that definitely has got a bearing on the health. And that's why we believe that that record also need to be part of the analysis. Yeah, and various kinds of analysis. I'm not going into too details of that today. The geotech templates, in fact, geotech data also should be part of it at some point. In fact, would love to look at that side as well, from the subsidence point of view of the bridge. And similarly, testing labs. So if we get while in the construction, these structures are, and if we get the test data and secured test data, actually those data can be very useful after some time. Because we don't have it. If you look at, and I know that I've been part of some of the large companies in the construction, right? What you have is during the construction, it's a fill it, shut it, forget it, right? How do we get that filled data not to be shut and get into and not to be forgotten for future? And that's what we need to do. And once we get that, we can do mind-blowing analysis on that. So we can actually take those data, as I said to you, that we can do the transition analysis. If you look at the middle part of it, yeah, we can get the temperature variations, the salinity, acidity of the water, which actually have a lot of impact on the bridges, especially like transverse sealing that we are making, or the Van der Waals sealing, right? Seismic data and the patterns of the seismic data we need to monitor. Otherwise, because it constantly, because of the vibration, constant vibration weakens the bridge, but to what extent we don't know. We only look at it from outside, again visually. Similarly, I talked about maintenance data, soil inspection data, material test report, and we are in the process of actually getting our solution actually scalable. That's why this is a blue. Actually, we don't take it at this point in time, but we are in the process of taking it so that we can do more holistic analysis. Now, the right-hand side, if you look at the advanced value that we bring in, not exhaustive, which is predictive, and some point in time, we'd like to do prescriptive analytics as well, which means is today you see a descriptive analytics. Time series is a descriptive analysis. It says what happens and when. It doesn't say why it happens and how it happens. Right? Predictive and prescriptive is why it happens, how it happens, and how do we actually prevent it. Some kind of, that's a little bit of time will be taking time, but important is if I show you some of the data analytics, and probably you'll be appreciating that what we are trying to say, right? Another is a residual life. How can we predict? I know I've got a data. I've got, all of us put, all of you senior civil engineers, you put a lot of sensors. What do you do with the data? Right? Not necessarily that machine sense will be coming in with the sensors and the software, and we need to have it, and then we'll be doing the analysis. No, what you can do is our software can work. Our software needs the data, otherwise I can't do the analysis. So if you have the sensors already set in, you can tell us what kind of data you've got. We can take it and we can look at it. How we can do the analytics. But important is we need to have substantial amount of data. If some data is there for 1 month, 2 months. Yes, some kind of analysis is possible, but if you want to see the signature of the bridge, which is basically how the deflection patterns are, how the recovery time patterns are, why it is happening, it is because of the weather, variation of temperature, whether because of salinity, whether because of earthquake or earth movement per se, right? If you want to do that, we need to have a lot of other data as well. But important is, let's make it a start. If you have done it, we can actually look at that, and it will be enriching the field itself. And that's why we believe that we can contribute to this world. Biplav, can you just take this slide, please?
Yes, thank you, Sudeep. So let me give you an overview of the initial sets of sensing mechanism of the sensors we have in machine sense. I already briefed you about the 3-axis deflectometer. So this is again a wonderful innovation of edge sensor technology, because we run a lot of computation on sensor edge here. And using that, we will be able to detect a deflection as small as 10 micron on resolution. Then we have ambient temperature, air temperature, humidity sensor, now, out of which air temperature is important because it gives you the surface temperature of the steel structure, which are very important because you'd like to know what's the temperature of the surface of the object. LBDT, as you always know, this is a good sensor to measure whether there is any gap, any kind of fracture that is coming up. You can monitor all kind of fracture. Then 3-axis deflection, 3-axis trace and state sensor is a traditional trace and state sensor where you will be able to figure out that 3-axis trace. Now, only innovation we have done probably this 3-axis trace sensor compared to the other people will be using it. We might be using the same transducer, but we also do a lot of edge processing, meaning we can correlate that what is the root cause of those kind of trace by connecting it with a vibration sensor or a load sensor. So that comes down to the next one, that is 3-axis accelerometer and vibration. Now, this one is also a good example of advanced in chip technology, because these are MEMS-based single silicon, vibration sensor were very small. It can be even less than half a centimeter in size. I mean, of course, we have made it like 1 centimeter because this has a steel housing in it. But we can sample the data as high as 5,000 samples per second. But normally, you don't need that. For most of the bridge monitoring, where you are monitoring the natural frequency, it is good enough to have 600 samples per second. That is my experience. Even 250 samples per second is also good enough in many of the situations. But if you have somewhat close to 1,000 to 2,000 samples per second in terms of the vibration sampling, you should be able to monitor even a fast moving truck. So what is interesting is that there is another use of this vibration sensor. Not only you can monitor the natural frequency, you can also monitor the load of the a moving track. I mean, we have done this experiment and figured out that a moving track load can be correlated with the 3-axis vibration, and that can be quick use because typically the load sensor, which is the next one, are very expensive. I mean, these are the typical load cells that you can put on the mat of any kind of bridges, and you can have 6 of them in parallel, 8 of them in parallel, and you can figure out what's the actual load in tonnage. Now, these are very expensive arrangement, but if you actually put a 3-axis vibration sensor and then use some kind of edge technology, very advanced correlation technology, then you should be able to figure out how much is the load from the vibration itself. And then, of course, there are seismic sensor. Now, seismic sensor is a kind of a modified accelerometer where we have to find out the vibrational wave. And that's what we do, SPN, other wave that we are doing right now. And it is very sensitive and it has a very high sampling rate. So over to you, Sudhir.
Thank you very much. Let me just go to the next. This is one of the things I know Biplav loves it, though not a civil engineer, but we kind of talked about it, is that XYZ again, the triaxial, why the triaxial stress.
Yeah. This is a good one. I just want to take 1 more minute to tell you exactly. So one of the biggest challenges, not only in the ICE code and to most of the structural engineers, again, I'm not a structural engineer, but I'm collaborating with many at this point. So any point of time you have this curvature in any of the bridges, as you know, that shear force, that is the force that will go tangentially, and somewhat outward because of the centrifugal force coming out of a moving truck. Now, that is very difficult to monitor without having a 3-axis measurement either in the trace or deflection. Now, at this point, prior to our innovation, there was no such great thing that could have measured 3-axis deflection. Now we are measuring this in our Utodanga bridge. We can measure the 3-axis deflection pretty regularly.
Yeah, this is important. Is I would just clarify one point again that yeah, I know some of the technology companies says that they'd also do 3-axis deflection, but again they use laser technology, and the Z-axis what is that called? Z-axis deflection when they measure, and when X and Y they measure, actually X and Y are less reliable than the Z-axis, and that's the technology they use. But again, I'm not saying some technology is bad or some technology is good. The technologies are changing. Even our technology is also probably after 3 years we'll have to innovate on the top of it. But I just for the sake of audience, I'm just talking about it. Okay, now next. So we have just some deployment. Just to let you know that Machine Sense, being a US company, having office in Baltimore as well as in Kansas City and in Kolkata. Kolkata, we have got around 50 to 60 people. And in fact, some of the brilliant PhDs actually are working with it, and some of the work actually I'll be showing it to you on that, right? And the data which have been gathered from various other bridges and what we are trying to do. It is not about that's putting the sensors. Again, that's one of the jobs that we do, and we do have partners as well. But important is once you get that, what do you do? Right? This is one of the live pictures actually from Calcutta. It's one of the bridges called Bagajatin flyover, and you see that the bottom curve actually is nothing but is that what I said, the descriptive what happens and when, what and when. So if you see the left hand side, I mean right hand side corner here, the vehicles are moving, and it will be showing you the almost on the real time the deflections are happening. You can see that the curve is moving, and then a small curve is moving. At some point in time, we'll be seeing a very large truck is going. I'll try to catch that. Yeah, this is a truck, and you see that this is the night time. This is another important thing in the AI, artificial intelligence. Artificial intelligence is not, it's not having its own brain. It has to be trained. Now, what happens is what we do as a mathematician, a digital practitioner, what we do is when we look at this kind of, large dip, that means a large deflections, we try to correlate with what kind of vehicle it is, what kind of loading that possibly it has. And we get a picture, but to validate that, this CCTV camera is working for us. And in fact, this is how you validate and make your algorithm correct. And what people have just talked about that, tomorrow, it's not so far. We are in the process of looking at deflection and trying to predict what vehicle it is or what is the load of that vehicle, right? Even we can go to that extent also. There's a multi-axial or single axial, right? We can possibly go there. We haven't gone there yet, but we are very close to doing that. So if you look at this is a truck, actually it is going in the night. These are most likely laden truck, heavily laden truck. And in India, it happens. And actually, the way it has come, if you look at this curve here, this curve is for that truck that you saw, right? Look at the deflection, right? So this is what we look at all the time, and this is 24/7, right? One. Secondly is it tells you the density of those trucks. See, another important thing is there is a difference between the static and the dynamic load. Static load is, I may get, if I do it once in 2 months or once in a month, I'll be getting probably this. But this kind of movement I'll be getting possibly if I do it 24/7 every night. So on a particular piece of concrete or a particular piece of material, if instead of 3 mm also 2 mm also does 1,000 times this kind of loading and unloading, possibly that gets weakened. So that actually talks about an insight, a possible insight into a material like concrete, which is a composite, right? It's a composite material. It looks like a homogeneous, but actually it's a heterogeneous material. So how does it behave? Now today, that kind of behavior you cannot do in any way other than visual. So we are saying that let's take a data-driven approach, right? And understand how the behaviors are. So basically, I just wanted to tell you this is from an original bridge. And this has been taken, I've taken it actually a little earlier view because to show the data, we need some kind of permission. We took permission some time ago. So we are showing it. But important is again, uh, uh, here, I'll show you an importance again on this. This is also a laden truck. You can see that. This is typically happens in the night. And this bridge actually got weakened because of the movement of such heavily laden truck in the night, right? And we actually recommended not to allow them through a portal. That's one. Secondly is when this goes down, as I told you in the last meeting as well, if you look at this bridge, actually is a little better off condition. And this is the Z axis only. We do have X, Y, Z, all three axes. Now, this movement actually has come back almost immediately. So, and it's a new bridge. Actually, there's an old, you can see that the other bridge which is the other direction. Actually, if this happens, the truck happens and it will be coming here. So the recovery is bad in that bridge compared to this one. I mean, worse compared to this one. So this is another indication of losing the elastic property of the bridge. And at this point in time, we don't know what is the end point of it or near end point of it. You being the civil engineer and the pundits in this area, possibly we can show that, we can throw that insight to you. At some point in time, we will be able to decide, no, after that, we cannot allow because it has lost its property, the desired elastic property, and it is not good for public safety. This is where actually we'd like to go to. Now, I'm just going in the interest of time. I'll have to just go a little bit faster. So again, so what do we do in the machine sense type? And the way we look at it, we do have the sensors, we do have the software platform scalable, which can take terabytes of data, multiple bridges across the globe. And we provide insights, data-driven decision making. This is next section. I'll be showing you some of the interesting curves, which we do, and we'd love to do if you call us. This is important one. The first of all, if you look at this, first of all, this is a vibration. It's basically vibration. We are saying a vibration. It's a 3-axis vibration. You can see X, Y, and Z axis, right? It's not a normal vibration. It is basically because of the loading it's happening, right? This is the way actually first we get. We see X, Y, Z, all three loadings. And look at not only Z, Y axis also is relatively important here. So even if you take a factor of safety on the Z, look at, in fact, this is an interesting data trend that we saw when we saw the Ultadanga flyover. The girder actually toppled because of 24-ton truck going at a 60-kilometer speed in the night, and it was at the curvature, and it toppled literally, as if somebody put a, just pushed outside, right? There was a shear failure. There was a problem with the, you all know that possibly there was a problem with the bearing. So important is Y and Z, both are so important. X may not be looking like that, right? So that's one part of it. Second part is, what do we do out of it? What we do is we look at, then we do the noise reduction. We may get it, you may see that there's lots of noise means lots of deflection. Actually, some of the deflection is caused by certain other elements. It could be seismic. It could be because of the weather temperature. It has got an effect on the sensor because sensors got a lot of metallic part, right? And because of the metallic part, they also actually create that noise on that. So what we do actually, we cancel the noise. And these are all algorithms that we use. We cancel the noise from the raw data to the process data, and finally we get what kind of. So if you look at the last one, is basically actual. These are the deflections. These are the it's the other side. So basically these are deflections data that we got for a certain amount of time, right? So this is showing you this again important thing. Not only the amount of deflection, important is also the frequency of those high deflections, which actually weakens the property of the material. That's what we are talking about. Now, this is also done for the seismic. Unfortunately, in Calcutta, there is no seismic sensor at this point in time, as far as I know. So next one is weather temperature. We know that when the temperature increases and the deflection actually is there. And how do you measure it? Possibly you do it again, NDT, put some gunny bag, etc. We are giving you 24/7. This is what exactly happens. If you look at February and March, how the deflection happens. X-axis is the deflection, and two curves. One is the colder time and the hotter time. See the deflection in the colder time with a similar type of load, by the way. We have analyzed the similar density is basically load density. we have taken. So similar type of load density creates, look at 7 times more deflection, right? So 7 times more deflection to the weather. So it will be easier to understand and predict some of the failures because the weather, because the, again, this can be done. This is for the temperature we have done. And we're also looking at, whether wind, you saw that Taiwanese bridge collapsed because of the wind, they are saying, right? So we need to understand which other sections are getting weakened, how it is weakened, and what are the, as I told you, why they are. It is not about what you have seen in the Kolkata bridge that we have shown. It is a why it is happening, how it is happening. Again, then we looked into the curve. If you look at this interesting one, actually, again, for the same stress, again, the same data actually we tried to analyze. The same stress is causing much more strain on the bridge, right? And this strain under the same load condition, if we try to project how does it look like, we'll show it to you. So we looked into that, how when the data, the scatter diagram, we put in the scatter diagram and we tried to look at how these variations are at different points in time. Clearly, right hand side, when we put in the normalized data, we can clearly see there's a pattern in a bridge. And this is the bridge that we are talking about, we are monitoring in Calcutta. And this curve may be different for different bridges. And that's why we say that it's a signature of a bridge. Right, signature of a structure, and this will be different for different bridges. Even though both are using M40 concrete or M25 concrete, it will be different because the weather condition is different, because the load patterns are different. Absolute load is also different. Loads are different dynamics there of the loads. As I said to you, 20-ton trucks at 60 km speed, at 20 tons of truck at 40 kilometers speed will have very different nature of y-axis and z-axis deflection. So I'm just trying to show you some of the stuff that, this is a comparison over a period of time that we have got, which is the blue line shows that when it gets weakened, how the deflection is, how much deflection is happening, and the orange line is showing actually under the same load, it is showing much lesser deflection, right? But we believe that our analysis will be showing in the next curve how it is progressing towards that. This is what we are trying to do at this point in time with the data. That means we will be able to tell you what is this timeline for this arrow. Is it 5 years? Is it 10 years? Is it 20 years? Depending on what data we are gathering. So I would really request you all to look into the data gathering part as important, but also looking into the, or looking or getting the insights into what's happening actually within the structure, right? So I would basically, this is for the bridge that we got, and we are trying to work with other companies as well. I'll come back to that. And similarly, it can be done. It can be done on the dam. So the DRIPS program is there in India and globally. It can be done, and probably dam will have much more than this because it is good upstream. We'll have to look at the scour. We'll have to look at other things as well, the silting, etc. Those things also will be coming in, and the displacement similarly for the tunnel. In fact, interestingly, I have taken up the co-chair for underground construction, digitalization of tunnels and underground construction. Obviously, this will be my subject very, very soon. Very specific subject. What do we do for a tunnel? Various things actually we can do, and we need to do it because we do have very strategic tunnels like Jojila tunnels and all. We need to be monitored. Otherwise, you saw the Japanese failure, and that's, I actually wanted to correlate between the two, the why we need that. And we have so much of tunnel boring machines are going the left to right and north to south in Mumbai or other cities. And we really need to monitor those vibration, because lots of buildings up there, and we need to have a precision mechanism, not the way that we used to do 10 years ago or 5 years ago, possibly. And actually, we can leverage a lot of new technologies, and we can experiment a lot of technologies if you say so. I think Biplav will be talking about this. I know we have only 5 minutes left, so we'll not be boring you to death. Biplav, you want to talk about, or I just quickly touch on it?
I'll be very quick. So one of the biggest Achilles heel in concrete bridge is the formation of concrete to the lifetime monitoring of concrete. I mean, unlike steel is more or less, you can say it as a homogeneous properties of material, which is not applicable for concrete, because quality of concrete depends on quality monitoring from the time of its formation to the subject of its abuse, meaning, how you are even maintaining those concrete. Now, this has been a worldwide problem. Of course, I know that in India, everyone loves concrete bridges, but everyone in the civil engineering fraternity knows the problem as well. Now, there is a collaboration we have with University of Padu, where Professor Luna Lee came up with a very important innovation. I mean, this is nothing new. Of course, people know that you can embed a piezoelectric sensor. So piezoelectric sensors are those where when you apply a pressure, you get certain amount of electrical signal. Now, as you know that a basic material inside any kind of concrete is different kind of metasilicates, and as they form the bonding, typically if you embed a piezoelectric sensor inside it, you'll be able to see different kind of electrical signal coming, and given that you will be able to mount it at a different direction. Now, what Lunali's work for the last decade, almost for 10 years, she has worked on this area and has shown that if you actually embed those piezoelectric sensor inside the concrete and monitor them with the algorithm, then you will be able to monitor the concrete from its birth to its functioning, meaning, once it annealed, you will be able to figure out whether it has attained its strength of material automatically. From that, when the concrete is deployed in the bridges, you will be able to see the aging of the concrete or any kind of weakness of the stress that is coming in. And I consider this to be very, very critical. But of course, the price will matter. So we are collaborating and see that whether this can be a democratized technology, meaning it should be able to use everywhere, so that we do not need to break our head over the fact that whether this concrete is right. Because right now, the way concrete monitoring is done by most of the civil engineer, looking at the inspection, or maybe you have some ultrasonic and other a little bit of advanced NDT monitoring once in a year, clearly that has been not sufficient to stop many of the collapse that we're seeing, not only in India, it's a global phenomenon. Thank you, Sudhir.
So it's an alternative technology. In fact, I was there in the last week, Trans-Harbor Sea Link office. Actually, I was talking to the project director around that. So obviously, they have the sound technology. So basically, it's based on sound. So I actually talked about it as well. So important is to all of you, sirs. We have taken the technology towards the next orbit. So, and we are ready to experiment in the civil engineering field, not only on the basis of sensors, not on the basis of how we do, but actually we can, as you saw that we are talking about data-driven industry, whether it's a manufacturing, whether it's any other field. And I personally believe, as a civil engineer, worked in multiple other industries, and civil engineering also can adopt data-driven future very, very well and quickly. So another important thing is that, as I said, that we're a technology company at the end of it. A technology company, we work, we're not very large, but we'd like to be large, but on the technology side. And we do have the global tie-up mechanism. We are working very, very closely with some of the company, very, very specific, like TestAI is an Airbus company. We are working with them. They've got very nice sensors which are spun off from the aviation industry. In fact, we are trying to bring some of them actually to India. Similarly, QuakeLogic, which is a very seismic oriented company, and we work with them in the US market for certain Californian region bridges as well as buildings. There's very seismic heavy. Similarly, we have recently gone to a tie-up with the TPF with Atul Bove's company, and with that, we are literally looking at work with Axelos, which is digital twin the steel structure. So that's a partnership. Like, this is the few of them, and we'd have multiple. I just thought that it'd be easy to talk about them. Similarly, the universities, actually, as people said, we are talking about Purdue, we talked to at Kharagpur, Maryland, as well as Fitchburg. Lots of other universities also there on the cards, because we are actually scouting for technologies for the civil engineering field, and we would like to take it to the next level into this. So why machine sense? So this is my favorite slide, and It's important that, as I say, that always we are the deep technology company, small but deep technology company, 20 plus patents that we hold. We have got 20% PhDs and collaboration, as I talked about. Another important is a global and niche technology we'd like to work on, because we don't want to go for something which is something is already there, but we'd like to innovate. We'd like to be at the edge. And we've got the capability to build the sensors. The sensor, you saw that most of the sensors actually, some of the components are obviously bought from the market, but we can build the overall hardware by ourselves in our Baltimore and Kolkata facility. And we are committed to making India Digital India as well through our Kolkata office. The last, very important for us, we do have end-to-end solution. We do have the sensor to the software to the advanced analytics engine, and the people who will be supporting all the way through. But we are not necessarily that we'll be working always from the sensor to this. We don't mind if somebody has given you sensors. We would like to take up that data through our software or through any other software to our software and do the advanced analytics for you. And that's where actually we believe that we can have a cutting edge. I think that's what for today. We are possibly overshot by 5 minutes. Sorry about that. So I'd leave it to now Prashant.
Thanks. Thank you, sir. No, actually, we started late, so you are just on time. Actually, you have a 13-minute slot for a sponsored presentation. Would you like to use that as well, or?
Let's take some let's do some question answer as well.
Yeah,
we'd love to. Yeah.
Sudeep Saab, namaskar. This
Namaskar,
is Gopal,
sir.
Dr. Rai.
Oh.
Thank you,
Hi.
Prashant. Let us take some quick questions.
Okay.
And let us from the panelists. I think it was very impressive. और ये मशीन हमें कहाँ लेके जाएगा मालूम नहीं, हम कितना सेंस करेंगे वो भी नहीं मालूम. ठीक है, तो प्रशांत, you can take the question hour. That is better, I think.
Before the question answers, I would like to take the comments from our special invitee, Dr. Lok. Sir, may I please request you to express your views on this pressing topic of SHM and how it's not just Indian but a global problem, sir. Dr. Lok.
There is no doubt, Majumdar, Sudip, that you have your lecture is fantastic. It opened our eyes, and I think health monitoring. I view structural health monitoring in the same way as any individual who monitors his own health. Well, when we are ill, we get a consultant. We see a medical doctor. If we have problems with the law, we see a lawyer. But when there is a structural health problem, we get every Tom, Dick, and Harry to do it. No, we shouldn't. We should get specialists. Get the specialists in, get the engineers in to monitor and to really give a better view of the health of that structure. I think that's a very important concept. And I think people are moving in that area, not just in India, but it's throughout the world. The problem is structural health monitoring, as you have indicated in your slide, one of your slides, it is still in the domain of universities. You look at all the sensors, you look at all the technology, you look at all the intellectual property, they reside in universities. I have people who are working on very complicated probabilistic theory to look into data acquisition. But what you said, I do have one simple question, and that is there a sensor to monitor the rate of hydration of concrete? Because if the answer is yes, then you can quantify the strength of concrete anywhere, anytime.
So I knew that Biplav will be jumping in here. So I'm expecting, because I know that what
that's a very good question, actually. So basically there are three ways you can monitor the strength of concrete from an embedded sensor. So yes, there are expensive sensor that can have hydrogen potential, looking at like what would be the internal water molecule content in the silicate. So that's already there, but these are not very popular. You have to drill it and find out that. And that's being done. The second thing is that for strength of concrete material, if you embed a piezoelectric sensor, as I mentioned to you, and you're right, this is again done in University of Purdue. So what they do, their structural engineering group led by Luna Lee, they embed a piezoelectric sensors. If you embed a piezoelectric sensor, again, you can have very well of young modulus and all the structural properties of the concrete inside. So that's another way. And we are independently trying a third possibility, because embedded sensor is not possible to the old bridges. So for the old bridges, the other possibility is we have a kind of a capacitance probe, a different kind of capacitance probe that we're trying to find out the water content, where you don't need to drill, because drilling is a problem many times to find out. So that's a third retrofit possibility that we are trying, but might be difficult. But as I'm saying, as of today, there are two definite possibilities are there which you can employ. One is that embedded piezoelectric sensor. Another thing is the embedded hydration sensor. Both are already available in the market.
Ms. Lok, sorry, just I must say that Dr. Luna Lee, actually, I'm speaking personally as well, along with Biplab. So it's a very promising. How much promising? Again, I would request some of our engineers who are there, senior engineers, to give us a chance to let's look at, because see why it is in the universities today, why it takes more time from lab to the field, because it doesn't possibly uh, it has got some kind of impedance in the civil engineering world, because we are too much driven by IS code and the Euro code and this code and that code, and we don't want to go outside the code because we are worried to take it to the code. But we need to create a sandbox, test sandbox, right? What we call it the test pit or the sandbox in the software world. We need to create. Otherwise, it will remain in the university. The moment it is out of the university, you test it out in one of the pits, and the moment you take it out, the cost will come down like anything, right? If you look at the way the technology cost comes down into 2 years from Zenith to Nadir today, right? So please give us a chance to take this kind of innovative technologies. Some of them I will not promise the entire moon, but yes, some of the innovative technology we can scout for you, try it out, and give it a chance.
And so I really envy your position as running the council for the digitalization of tunnels and underground structures. If you look at every major city in the world, there are tunnels, new and old, and they need monitoring. And I envy your position, because this is the way forward. Congratulations.
Be my advisor, please. I'd love to learn from all of you. Yeah.
Dr. Prashant, can we invite Dr. Surya Prakash?
Yes, sir. May I please request Dr. Surya Prakash, sir, to provide his comments on the topic? And
Right. Yeah, thank you, Dr. Prashant. I think, first of all, good evening, greetings to all the esteemed panel members and the speaker. I think Engineer Sudeep Mazumdar as well as Dr. Biplab have done a fantastic job in giving an overview. Especially, adopting these modern technologies is the way to go. And a nice summary. And also we got to know what type of new different sensors are available and how they can be seamlessly integrated for continuous acquisition of data, that too in a remote manner. I think that is going to be the real key, the remote collection and analyzing the data. And also, it's just not about acquiring tons and tons of data. What do you make sense out of the data in terms of engineering parameters? It could be frequencies of vibration or deflections or accelerations, from the threshold limit, where we are able to quickly intervene and do something about it. I think that's going to be really key. In that process, the remote monitoring would really, really help. And I think we have a fantastic overview. I just have one comment, usually what I understand is from the cost of the new project, especially important projects, the way I understand is the total implementation of this SHM systems, if you take a bridge, it comes around about 2%, right? In a conventional setup. But when you go for this kind of remote monitoring systems, how much the cost would increase or decrease? I mean, what are your comments on that?
Okay, sir. I must say that something should not be looked at from the cost perspective. That's what I believe. The 2000, I bid for some of the large bridges like 1400 crores to 2200 crores bridges of NHAI, right? And I saw that it is coming to anything between 5 to 7, 7.5, 8 CR, right? But if you look at percentage term is nothing, right? The amount of data that you can get, and see, ultimately, what are you trying to do? One is enriching the civil engineering field. I think I take that sense of purpose, right? And that is why I left my L&T's job. I am leaving my CDIO job and going into a completely startup because I believe there is a sense of purpose. I'm not saying that, that you believe in me, but I have got personally a sense of purpose. So I think important is from the civil engineering point of view. When I looked at for the last 5-7 years, when I came back from banking and insurance to retail, all this industry to civil engineering field, and I saw, just give an example, sir. I'm sorry, I have told it to DKS and all senior guys in many senior guys in L&T. I said that, you know what, in 1990, being a civil engineering student, I was in Durgapur Steel Plant for my internship. I did it for EPIL, Engineering Projects India Limited, right? And that time I saw how people are actually taking notes on cube testing results in Durgapur Steel Plant in one of the buildings. I saw the same thing in Jalpaiguri in one of the road projects. The same thing is happening in 2017. 1990 to 2017, sir, we could not do a simple mobility enabled stuff. And this is where actually in fact, I was very disturbed at that time. And I'm very passionate on certain subjects, right? Because digital is my bread and butter. And I told actually the head of quality, Mr. Sen, who is the director, I said that, sir, you have done a lot of things in life, but 27 years, IC civil engineering has not progressed a simple thing. A lot of things can be done, and I would love to get there. Possibly this is not the platform, but certainly some of the things should not be looked at from that 6 out of 2000 is nothing, sir. 6 crore out of 2000 crore is nothing, right?
Yeah.
Not even a 0.2, 0.3% in terms of the cost, but the amount of data, the behavior. If you get hundreds of bridges, I can predict possibly the concrete behavior in general. I spoke with one of the professors in IIT Bombay. He told me he's a concrete technology professor. So I used to have an innovation lab with KEC at some point, and he was my advisor. He told me, Sudeep, I'm a concrete technology professor, but actually I know nothing. I'm still a student, just like you. So concrete is still an unknown beast to that extent. So I would say that, don't look at it that way. The more you adopt technologies, the cost will come down automatically. Today, what is 6 CR? Tomorrow, it will be just 2 CR. What is 2 CR today? Very easily, it will be 550 lakhs, nothing else. Yeah. So that's why I'd like to get.
Professor, can we take from Bongirwar sir is there, our eminent expert and you can say biggest client. Bongirwar sir, let us have a quick opinion from you. Sorry, Prashant. We need to rush.
Basically, if you take the city of Bombay, there are a lot of very critical bridges. Even our Maim Causeway has already completed more than 50 years. Even the Bandra Arobi going from this road to Western Expressway has already completed 50 years. And there is no alternate route to them. So there is a time that we monitor the health of these old bridges, especially in the urban area. And if there is this additional tools available to us, we should definitely use them. There is no doubt, because there is no alternate route also to us. I remember, and after the first Thana Creek mishap, we constructed new Thana Creek bridge, and we have installed some instrumentation to monitor health. But I don't know who is collecting the data, whether anybody is analyzing the data or not. So if the data is easily available on the screen, then nothing like that. That would be a very ideal situation. Let's take the Bandra-Worli link road also, where we were first to do the cable stayed bridge in a long term, etc. Or a new coastal highway, where we are for the first time we are going for maybe 3-meter diameter pipes. So these are all something which need to be properly monitored, so that even the Codal committee will get some insight regarding what parameters to be studied. I can go to another instance. Recently, one flyover in Gurgaon had fallen down. The reason attributed is the lack of strength of the concrete. We had a similar experience in Santa Cruz flyover, where segmental construction, we stretched the segment and then the whole thing collapsed. The whole thing, it got cracked. So if you got some instrument to know whether the concrete has really gained strength, it will be very useful and ideal, especially in such a delicate situation.
Yes, sir. Yes, sir.
Yeah,
And the adoption of technology bring down the cost. I can narrate my experience. My first flyer costed me 25,000 rupees per square meter. In the 4-year span, my cost came down to 12,000 rupees per square meter. Only because people got used to the new technology. They had all already owned the modern piling rig, etc., other equipment. Therefore, cost came down. So we need to start some beginning, especially in all old urban areas. There are bridges having more than 50 years, 100 years old, and they can create a catastrophe because there is no alternative. Let us start some bridges in Bombay.
Agreed, sir. Yeah, Dr. Harshvardhan Subbarao, this time you are first. I'm sorry. Can you unmute yourself?
No worries. I'm happy to speak anytime.
Yes, sir.
In turn or out of turn. Sudeep, wonderful. Dr. Biplab, also wonderful presentation. It alerts us to many things that are probably lacking in our compartmentalized vertical silo way of civil engineering that we go about in India. But the larger issue is still at large. How do we implement these into tender documents? Is it the whole set that we're looking at? Are we trying to talk about the whole bridge stock? You've taken few examples, but to make it generalized and to apply the algorithmic strength that you have developed, that will require to look at the entire bridge stock. You need to look at classification and bridge stocks and then look at modeling those deteriorations, modeling those times to get the predictive models correct and set. The learning that you talk about, the use of machine learning and deep learning, that machine learning, someone has to train. That training has to come from experts who are people who are in this profession. The training for this bridge stock is a bridge man. I mean, a bridge sensitive person. So we go back to the point of the subjectiveness of the expert. And also it's like what we're talking about is artificial intelligence, and we're talking about forward chaining and things like that, which has been around for 20, 30 years. But the point is the subjectiveness of the expert, that still will remain at large, to set up the rules for your thresholds, to set up the rules at which you cut off, to know what you're getting data, but to set the thresholds require expert input. Now, whether you can do it from codes, because the codes may not have them right already. As you just showed, some of the codes are way off the mark because they are, they are based on mean value type of approach, and it's not a fully probabilistic model in any case. So you are bound to have that deviation, okay? And the log normal rule that we apply for the loading side, I mean, that may not be appropriate for all the loads, for all the loading. So there are so many issues which have to do on the load side with structural reliability not being properly implemented and understood. On the resistance side, which is, say, a factor like the strength of concrete, you've got a wonderful device, the piezometric change in pressure, predicting and correlating, as you also showed the piezometer being used and adapted to other things like temperature, and it's a very versatile device.
Yeah.
It can be used for various things. So the point really is to calibrate that with respect to a whole sort of bridge stock. And the calibration would be with age, would be with type of bridge stock, would be with type of bridge element, would be with type of loading, would be with type of temperature, all that. So actually you are going to then develop, I think your end goal is to try and develop a fully predictive corrective model, which is having all the rules-based work that you need so that it's not only the data, but the prediction as well as the solution finally out of that. That's the long-term look in the view that you've projected today. How do we go about this? The point is now, how do we go about something like this? Is it one expert, two experts, 3 experts, 50 experts? What would be useful, Biplab and Sudeep, is to develop a sort of a heuristic questionnaire or a set of rules, a set of questionnaires that you might want, which might help you increase your models, the model side, so that they are more realistic to the Indian situation. For example, I'm investigating one particular bridge in Delhi which has collapsed. And in that, it is pretty clear, the reasons are pretty clear why they are. But this is more a human characteristic, it's what we call normalization of deviance. This is a term in risk and hazard thinking, which we call the normalization of deviance. It's a very standard term, but that is what has happened. The chalta hai attitude that, you know, it's okay not to check some particular matter, some particular parameter is okay. You talked about cube strength. That's not the be all and end all of life. You know, that's nothing. So the durability based parameters are simply not measured. And it was a durability issue that led to honeycombing, which led to a very poor concrete strength at the soffit where the demand is maximum. And at a normal pre-stressing on a launching entry, it failed. It crushed, the concrete simply crushed. Now, to overcome things like this, it's not only the monitoring. You can't monitor the piezometer only in the casting yard, and that it has to do with the change in human approach.
Behavior.
You know, this is behavioral issue. So I still think that in spite of having all the structural health monitoring that you may have, to get it right the first time is the most important goal of the civil and structural engineer. Monitoring could come next, but if you've got it wrong at start, God help us all. You know, I mean, what's the point of monitoring something when you're not prepared to get it right first time round? We have to focus on that also. That's it's a twin hammer. You know, you got to do both.
Sure.
Thank you, sir. Thank you. Let us hear from our DG, Duty, sir. Director General, Duty, sir.
Bhai, good evening, everybody.
Namaste,
Today's presentation by Engineer Sudeep Muzumdar and his colleague is really very, very interesting and educative. I find it useful for our many bridges in your Indian conditions. In Indian Railways, there are thousands and thousands of bridges which are 100 years and 125 years old bridges of different types. They are arch bridges, they are steel bridges, and constructed out of stone masonry, brick masonry, and so different material. And today, even though these bridges are looking sound, they are looking sound, but technically, unless we certify, it is very difficult to say that bridge is fit to carry the today's axle load. When the bridge was constructed, it was constructed for meter gauge loading. Now that meter gauge has been converted into broad gauge. Then initially the load was 18.5 tons per axle. Now those axle loads have been increased to 25 tons per axle. So unless we analyze the strength of this bridge or the residual life of the bridge, it is very difficult for the engineer to certify that bridge is safe to carry the load. So the presentation given by Sudeep Muzumdar.
So we're losing you.
Perhaps may help to for their soundness and for their residual life. Now coming to recent construction, I was the chief engineer of Konkan Railway, and we constructed number of tall bridges, tall viaducts. The tallest was 64 meters, but other bridges are in the range of 40, 45, 50 meters height. Now today we are depending only for visual inspections. How long we can depend upon the visual inspections? So for such type of bridges, the technology end-to-end solutions proposed by Sudeep Muzumdar, I think will be useful. We have to go for that. So the presentation was really very interesting and will be helpful for all the engineers. Thank you.
Thank you, sir. Thank you, sir. Let us invite Prashant. SK Suri, sir. SK Puri, sir.
Good evening. You see, I joined the ministry in Bridge Directorate 1976 for the last 45 years. I have been associated with the bridges. I think most of the things Engineer Devate has already touched upon. It's nice to know now that, serious professionals have come up, joined together, and they are as a company, and then they have this patented, whether 20, 25, whatever the instruments. You see, even in the ministry, repeatedly we have done bridge monitoring, health monitoring, what you're saying, bridge survey. But it was all physical and visual, and nothing actually happened. There were two things. One, uh, those who were doing, I'm not sure they were sure of everything. Those who had to take decision, they were also not sure whether it is actually going to help in the, because we have to find the residual life. I'll give you the live example which now I am facing, being a engineer and authority engineer of some of the projects of NHI and ministry here, that in 2 lane to 4 lane or 4 lane to 6 lane, there is an existing bridge is there. And you know, existing 2 lane bridge or 4 lane bridge, uh, just maybe the during design DPR, physical observations are done, and it is, you know, retained that this bridge will be retained. It is okay not to be constructed new because the cost is involved. And during the supervision, when the work is going on, when we actually are at site and when we critically look at the bridge and we find that this bridge is hopeless, it will not, it's not going to last next 5 to 10 years. And therefore it has to be, new construction has to be done. And then there is, you know, change of scope. So all kind of contractual issues come. Now it is up to Mr. Majumdar and his company and companies like them, that having all these tools of today's modern tools in their hand, how can they chip in so that, because you know, if there are something we are constructing and it is a bad construction, that's a different issue. What we are looking is that all those bridges, now we are looking at the bridges constructed even in 80s and 90s, they are also failing. They also need, you know, massive rehabilitation or reconstruction. And some of the bridges which are 70 years, 80 years old, which were designed only for 40-ton loading, today our vehicles or our design is 100-ton. Even they are okay and they are going on. No need to change. So I think is the need of the hour. We really, the profession needs this monitoring, proper scientific. So that means whether it's a digital technology or whatever technology, but a scientific technology, so that people have faith, people, you know, it's in black and white, they can understand. And then one of the main things comes to all the, whether it is state PWDs or NHI or the ministry, it is a, you have to convince the finance people that this money is required for this. And one, paperwork is required, data is required, and certification of a credential. Because you know what Mr. Majumdar was saying, why we are going to the universities, why we are going to the professor. The only thing is ISI mark. ISI mark. That means the IIT or some professor or somebody has given his seal, and therefore it is okay. So I will close at that. Don't want to go into.
Yes, sir. Yes, sir. We agree.
Thank you.
Thank you, sir. RK गोयल सर 1 मिनट है, उसके बाद हम लोग रिटर्न क्वेश्चन आंसर 1 मिनट.
Okay, I had many issues to tell, but since you have given the time limit, so I will try to confine in that. First of all, it's a very fascinating type of a presentation. It has covered many things, right from the different aspects of health monitoring to ISCOBAR monitoring, seismic data, acidity of water and whatnot. It's a very, very fascinating type of a presentation. And one thing I would say straight away, the ISCOBAR monitoring is a very good area which the railway is very, very interested, and we are also going for this type of monitoring, continuous ISCOBAR monitoring in all of our bridges where the foundations are deep in the water perennially. The aspect which I want to say, when we say of bridge health monitoring, I don't know, in railways, when we talk of a bridge and about its health, we first of all look at the bearing. And this aspect of bridge bearing has been missed in your presentation. I do not know why you are not taking care of the bearings. You have to do something about the bearings.
we do monitor bearing. The data was not shown. You're absolutely right.
So
I
now,
mentioned once.
okay, no problem. And another thing which I am very fond of, I have liked it in your presentation, is very fascinating. You have shown the recovery, bridge deflection recovery, and how it is changing with time. Old bridge to new bridge, and depending upon time, how it has taken more time over a period of time. Actually, this is again related with the bearing, condition of bearing. For the friction of a bearing will keep on changing. That's why we have a schedule of oiling and greasing of the bearing. If the recovery, if you want a regular recovery, you have to ensure that the friction remains at the same level. So all these things are correlated. So this is a very good area. And one topic was why this bridge health monitoring is not reaching to the field. The reason is because there is lack of interaction. Not many, we need more frequent interaction with the field people. I think IIB is one of the forums. We need to interact at different more forums probably. So with these limited remarks, I close and then let us go for the question and answer. Thank you,
sir.
Dr. Prashant, you can now take the rapid hour question hours, what is posted in the lecture. And Sudeep ji, over to you, and Dr. Biplab sir, over to you. Prashant.
Thank you, sir. So we have 16 open questions. If I could pick one from Dr. Sanjeev Garg, Deputy Engineer Designs, Northern Railway, he wants to know if there is possibility to measure the residual pre-stress for bridges. Do you have a system for that?
So it's all about data. So if we have the as Goel sir also said, that starting from the deflections and the recovery time, that's a basic, like it's a function, it's an objective function, and which are the factors that are affecting that? It's a load pattern, weather, change of weather, bearing, the bridge bearing strength, to even the scouring, sky seismic. These are all actually variables. We can do a very good analytics on the top of it, but first is getting the data of that bridge or a particular bridge is important. Possible.
So, just to mention this, see, there is a difference between NDT and 24/7 monitoring. In 24/7 monitoring, you are getting the data for day in, day out, night, every time. So if you see that any kind of pre-stress condition is a function of time, what time you think is this, so you'll be getting data for all kind. You just have to mark that particular time instant. At this point, you can think the data is closest to the pre-stress condition. That's all.
We can. Answer is we can. Yeah.
Okay.
Can I just add to that one point, Sudeep? It's all the data that you collect goes into probabilistic models and probability distributions. Am I right? It's not mean value. So you are looking at distributions. Am I right or am I wrong? You didn't show that. So
no, let me put it. So we are taking data science approach.
Okay.
Statistical approach is doing a regression and project.
Right.
Data science approach is take all the data, try to find a pattern. Just the opposite, right? Where they meet is basically, we know that a lot of data science are advanced statisticians as well. So we generally don't start from the ground and say that, what should be the regressive pattern, but we actually look at the billions of data point and try to find out a pattern for different ways.
That was my point, that you need to look at bridge stocks if you need to make a realistic impact. Looking at individual bridges makes no sense.
No, that is why, sir, if we get 100 bridges,
that's what I'm saying. You need a bridge stock.
Yeah, absolutely. Yeah, absolutely.
To get this, because it's
He
not
is right.
probabilistic.
We need more bridges. But just to answer your question, another thing that so there is a data lake. So data for all sensors will be coming in, but then you have to answer the real question. So for example, in the Bagajotin bridge, the data that Sudeep shown, the beach committee wanted to see whether there is a lot of illegal truckload of sand, like wet sand track that goes on the beaches, and that was the main reason they believe that is causing the damage to the concrete. So we had to find out from that data lake, whenever we are seeing a deep impact from the trucks, which is possibly loaded with the wet sand, at that time, is it that it is impacting the bridge more than others? So, after the data lake is all being collected in the cloud, you can ask us, okay, give me this answer. I suspect it is because of weather. I suspect it is because of this. I suspect it is because of the illegal tracking that is causing the damage. Can you answer this question? So that's what then we can, gear the data towards that.
Yeah.
Thank you. Thank you.
Prashant, can we take next?
Yes, sir. Among the other questions, they were just mostly compliments and wishes to you, sir. But there's one important question that I think should be answered. It's asked by Mr. Shan Mugasundaram, and he wants to know that what is the lifespan for these monitoring system? I mean, if a contractor or the railways pays for installation, how can you can maintain them? I mean, are they weather protected? It's a one-time cost or it's an annual maintenance cost? How would you like to answer that, sir?
To answer quickly, that generally we feel that, that's whether it's first a weather protector or not, basically the casing, which is IP67, 65, whatever is the requirement. The more the IP numbers you pay, your payment has to be a little bit more, because that's controlled by an IP67, those polymers. That's one. Generally, I think Biplab will be the best person for that, but still, I'm just in the interest of time. 4 to 5 years we can think of, and we always think of that. There will be some amount of changes. That's why wherever we quote, we say that around 10% redundancy, 10% theft, something like that. We have to always keep it in mind. But obviously, the more the remote position you put it, the less chance of theft. The other way around, actually. So it's better that we do the remote bridges first. Nobody will cut the wire.
The other thing is the cyclone, Sudeep. So in our experience in Calcutta, so
Yeah.
every time a deep cyclone comes in, so it's also important to be very much cyclone proof, and especially on the coastal area.
Yeah.
So we have to take all those things into account in our cost modeling.
Absolutely.
Thank you so much. I hope, I think that's all mostly the questions, and rest was comments and wishes, sir. Over to Dr. Gopal Rai for the vote of thanks.
Gopal,
One more thing, I think
Gopal, can we raise a few points more? Are we out of time? Some
Sir,
discussion.
सर इंडिया के हिसाब से 8:30 बजने जा रहे हैं. यूएस के हिसाब से नहीं. We will have more interaction one-to-one when we have. So that because the participants are going low, so we request that let us conclude here, because this is actually
very phenomenal
ending topic, right?
This is the subject. Actually मैंने ये जब when I was मतलब हम लोग बचपन में हमारा सबसे पहला सेंसर था लिफ्ट. जब हम जाते थे तो लिफ्ट खुल जाता था और आते थे, तो दिस इज द फर्स्ट सेंसर फ्रॉम द चाइल्डहुड वी हैव सीन. सो द सेंसर वर्ल्ड इज गोइंग टू एंड हाई एंड एंड. लेकिन उसमें मेरे को एक चीज लेट मी टेल यू विद द शायरी एंड रिमार्क, क्वेश्चन मार्क ऑन सेंसर्स. लोग हाथों में सेंसर लिए फिरते हैं. लोग हाथों में सेंसर लिए फिरते हैं मींस पीपल कैरी अ सेंसर इन अ हैंड. ओके, कोई हमें सही मर्ज तो बता दे. कोई हमें सही मर्ज मतलब एक्चुअली विथ योर सेंसर इफ वी कैन डायग्नोज द करेक्ट प्रॉब्लम, देन योर सेंसर्स आर यूजफुल.
Right.
Otherwise, so that is the gist actually. Although my PhD part, I have put a lot of sensors, but my professor told me, Professor Abhijit Mukherjee, Gopal, unless you diagnose the problem, it is useless. So we should install a sensor to actually correct problem we should identify. I'm not an expert in sensor and health monitoring. I apologize, because two machine sense and novice big experts are sitting here. I'm nowhere. I'm happy in retrofitting and rehabilitation. So no ways I don't want to take. So let me begin my Dr. Harshvardhan Subara. I'm sorry, but let me conclude here. Let me thanks today, Professor. First of all, today's like last time sponsor and today's speaker, Machine Sense, all the team, Dr. Biplab Pal ji. Namaskar, sir. बहुत बहुत धन्यवाद. Thank you very much for supporting
IIBE.
IIBE.
Enjoy your शायरी. I think you should have more of the शायरीज in between.
सर मॉनसून है, थोड़ा सीजन नहीं है और बिजनेस नहीं है, तो थोड़ा शायरी वरी कर लेते हैं सर. So that is the part, and it is कटाक्ष होता है सर शायरी. And thanks to Sudeep Mazumdar ji. Thank you very much, sir. And thanks to all Machine Sense team from abroad and from India. And we really look forward that we see number of Machine Sense installed in all over in India and all. Lot of specifications should come. The beauty of IIB that all people you are seeing here, they specify the things. All are consultants. Okay, so it goes in a left and right and top and bottom. So really, it's a good platform. Thank you very much for presenting the part. And let me thanks to the third Professor Lok. Professor Lok from I know Professor from last 9 years. He liked my jacket. That's why I wear the jacket. Okay. So Professor Lok, thank you very much. And I like his health monitoring, the thoughts. He think of monitoring small things. So thank you, Professor, for coming. Although he's in right now in London, monitoring Singapore from London. Thank you, Professor.
Thank you. Thank you very much.
Gopal, may I say something? Just 30 seconds.
Yeah.
The beauty of this monitoring is actually you can create a command center sitting in one place and monitor hundreds of bridges and their health and why they're happening. So what Lok sir is doing is absolutely feasible. We'd love to do that for others as well.
You should thank to Corona. He's stuck in there. That's why he cannot move down. That's why he's monitoring Singapore from London. I think that thanks we should give to Corona. दीपिका, एक क्वेश्चन मैं चाहता हूं आप पूछे आज. दीपिका सिंह, मैं चाहता हूं आज सवाल आप पूछे कि in project planning whether this sensor system will help. Over to you, Deepika, Engineer Deepika.
Thank you, Gopal sir. Actually, what we are as a BIM and project planning consultant, we are already developing building information models. And in that, one scope of adding sensor that we have observed is that during facility management stage, so when we collect information of the bridges and we post, we basically create a model that has all the information. So when you link that information with those sensors, for future purpose, like a lot of tools have been already developed, so you can just the sensors will start giving you data, and you can actually open it in your system and check which area of that particular infrastructure requires the I'm sorry, like the inspection, which area needs. So that is something we are also looking forward. So I am very much interested in seeing how machine sense will help in that kind of technology, like before the structure is built. So if we can plan that beforehand,
Correct.
so we can have a model ready with us, and while construction we can take care of, we'll develop that complete information system. And then when the model, when the structure is completed, so can we do something like that with machine sense technologies?
Good, Deepika. In last 24 lectures, this is the first question I asked, and first time you have replied. Thank you very much, Deepika. Thanks, Swapnil. This is Deepika represent from a company Swapnil Intento. They do a project planning all over globe. Okay, thank you, Deepika. In between, vote of thanks I have taken. Sorry. Let me thanks to all the panelists. Let me thanks to all the experts. And today's panelist, अगर मैं नहीं बोलूँगा, so Dr. Surya Prakash, तो मुझे बहुत फायर करेंगे. Thank you. He just got well. Earlier he was telling that Gopal, it will be difficult to talk, but hope all is well, Professor. Professor Surya Prakash, thank you very much for accepting as a panelist. And let me thanks to today's moderator, Prashant Motwani, Dr. Prashant Motwani, a young a researcher or PhD from IIT Bombay in health monitoring and sensor and all. Really, when sir has told that lecture, then I thought there should be. This is the first time, that like two healthy competitors are coordinating each other and they are doing the work. This can happen only in IIB only. So thank you very much for all. And let me thanks to our EC member, Executive Committee member of IIB, to all who participated. Let me thanks to Director General Dute sir, President Vinay Gupta ji, and to Ruhi Agrawal and Deepika Singh for all coordinating, our Huzefa, who coordinates all the Zoom and all coordination part. And special thanks to Novis for sponsoring this talk. This is good gesture. I think this is called, like, we should sponsor our colleagues, and that's a good gesture. Thank you, Professor Lok, for supporting and giving some financial aid to IIB. We'll make some money and we'll have we'll make more lectures and all. We are looking for all the members. Let me, to all the people who are there, become a member of IIB, because very short, we are coming up with the plan that only members can attend the lectures. Okay, so that will going to come in the days. So request all to become a member of IIB. It's a very small amount, and although in last 1.5 years we have made 24, 26 lectures all over the globe. Thank you very much. Anything, sir? Anything pending from my side? Sudeep Majumdarji, anything I am missing?
No, thank you very much. Thank you. It's a pleasure talking to all Pandits here. Again, I'm also Minoj Gopal, just like you. I'm learning, though I've graduated in 1992, but not much of worked. I have not worked in the civil engineering space, but I'm liking it over the last 7 years. Yeah.
सर ये आज काशी विश्वनाथ गया था तो वहाँ टिक्का लगाया था. Thank you very much.
Thank you.
Thank you guys. Good night.
Thank
Have a
you,
good dinner.
everybody.
Good night.
Thank you,
Good
everyone.
night.
Thank you all.
Thanks
Thank
so
you.
much.
hard
Very
thing.
interesting. Thanks so much.
Thank
No
you.
hard
Very
thing for that.
Very, very interesting.
Thank you very much.
Thank you. Thank you, sir.
Yes.